This meeting is being recorded.
In problem 2.9, we were asked to draw any missing lone pairs on oxygen atoms. So in 2.10, we're asked to do a similar thing here, but now with nitrogen atoms. So we'll take a look at all of these compounds, and they tell us to try to do this without having to count. So that means without having to calculate formal charge. So let's take a look at how nitrogen likes to be neutral. It tends to have 3 bonds, it's trivalent, and it has a lone pair. So this is how we find neutral nitrogen. So let's take a look at these compounds, and if they do not have a formal charge, we should expect to see 3 bonding pairs, and then we would fill in 1 lone pair. So compound A follows this pattern. It has 3 bonds coming out of the nitrogen, so we would place 1 lone pair on that nitrogen, and this would fill the octet. Same thing with compound B. We have 2 alkyl groups, and then we have a hydrogen bond to our central nitrogen. So 3 bonding pairs. We're going to also have 1 lone pair. Next, we have with compound C, we have 3 R groups, 3 alkyl groups. So again, 1 lone pair. Now, when we get to compound D, notice that there are 4 bonds and a positive formal charge on the nitrogen. So that means that the octet for nitrogen has been filled by all these bonds, and we would have no lone pairs on this one here. Now, compound E is the opposite. We have a -1 formal charge on our nitrogen, and we see 2 bonding pairs. So this would indicate that we would need 2 lone pairs on our nitrogen. Compound F, we see our pattern emerge again. So we see 3 bonds, and that would indicate that we need 1 lone pair for for nitrogen's full octet. Compound G, we see again a +1 formal charge. So those 4 bonds are filling the octet. So once again, we see no lone pairs on this nitrogen in compound G. And then again, with compound H, we see 2 bonds to a carbon, 1 to a hydrogen, and 1 to another nitrogen. So last for compound H here, we once again see our no lone pairs. And this is everything for this question here. If we were to count, for example, though, let's do a formal charge calculation real quick for E here. So when they tell us to count and see if we were correct, we would use our equation for formal charge, which would be the number of valence electrons. So we go to our periodic table, we see nitrogen's in group 5, and then we subtract the number, half of the bonding electrons. So that would be 2, or we could just count the lines. So lines plus all the lone pair electrons, or the dots. That would be 4. So we have 5 minus 6 gives us that -1 formal charge. So if you're unsure if you were correct with your quick analysis without having to count, you can always do a formal charge calculation like this.